Good afternoon, class. Today we're going to look at solving nonlinear inequalities using cut points. Really, any sort of inequality can be solved using this method, provided there's a solution to be found. Even linear inequalities. Let's switch over to my camera. We have a sequence of steps that we're going to follow. And I should mention, this handout is stored under Files on Canvas. So if you lose it, you can download your own copy. It's under Files on Canvas. Let me confirm that. Hold on, let me confirm that. Where's Canvas? Oh, let me do that. Files.
Oh, wait, should you look at?
Oh, I'll look at student view, so it looks like y'all's. Yeah. And there it is, the cut point method for solving inequalities. You can download it. Here's just a preview of it. It should be exactly what I have there. But
it's
let's
nice
get
for them
started.
to have a copy while you're doing it.
Yeah.
So they can be looking
agree.
at it. Give it to me. I'll get a side of it.
You know what? I don't think we need Canvas anymore. I don't think we need that either. Okay, let's switch over to there. Okay, first of all, what do I mean by an inequality? We know an equation is any expression that has an equal sign. An inequality is any expression that contains a less than, a greater than, a less than or equal to, or a greater than or equal to symbol. I think the best way to approach this is to just start off looking at an example, reading through this recipe of ours, and following the steps to arrive at a solution. To illustrate, let's look at number 1 in the homework. That mouse is getting really tricky. Have you noticed? Okay, let's see. We have x squared minus 11x plus 24 is greater than 0. Notice the instructions just say solve the inequality. They're not going to say solve using the cut point method. It'll be up to you. When you run into an inequality in this class, you're going to have to know that you're going to use the cut point method to solve it. We'll use cut points to solve all of our inequalities. Let's switch over.
So what you just said is anytime you see one of these symbols, we're going to follow this step. I mean, this sequence of steps.
Okay. The first step. Replace the inequality with an equal to and solve for x. The numbers we get here are called solution cut points because they're solutions to the equation. And I'm going to abbreviate solution cut points with the letters SCP for obvious reasons. First thing we're doing, I think I'll number the steps here. I won't always do that, but since this is the first one we've done, I'm going to number the steps. This is step 1. Set x squared minus 11x plus 24 equal to 0. This is a simple trinomial. I think we can factor it.
And what made you decide you need to do that?
Because it's quadratic.
X squared.
X squared, either factor or the quadratic formula. The fact that it doesn't say that you may need the quadratic formula makes me think that it's going to be factorable. X squared, well, it's a 1, so 1x times 1x. We know something nice about the signs. What do we know about the signs? Okay, wait a minute. The last sign's a plus, so you have 2 of the first sides. So you have 2 minuses, minus and minus. That's the nice case, because then you can fill them in automatically. If it's a plus and minus, then if that last sign's a minus, remember you have 1 of each. Well, where are you going to put the plus and where are you going to put the minus? So this is the nice case. What times what gives me 24? We can have 1 times 24 2 times 12, 3 times 8, 4 times 6, 5 doesn't go in, 6. That's why I write these things numerically like that, because 1, 2, 3, 4, mentally I check 5 doesn't divide evenly into 24, 6 goes in evenly. I've gotten this number here on the right hand side, so I know I've found all the pairs. This is a simple trinomial, so it's easy to choose the pair you want. You need the pair that's going to add together to give you what number? 11. Which one? Okay, so I'm going to use 3 and 8. Set each factor equal to 0 to give me x equals 3 for my first solution cut point, and x equals 8 for my second solution cut point. We have 2 solution cut points. These cut points are going to be labeled on a number line. That's what I was saying at the end of class the last time. Look at the little recipe. These solution cut points, these numbers make the left side equal the right side. Is equality allowed on this problem? Can the left side equal the right side? If equality were allowed, it'd have to have that little horizontal bar. Do we have it? No, so equality is not allowed. That means you don't want to shade those cut points. They don't satisfy the inequality. And we spell it out right here. If the problem contains a less than or a greater than, you're going to have to use less than or equal to or greater than or equal to, you're going to have to use a closed circle. If it contains just a less than or greater than, that's what we have here. Just a greater than, you'll use an open circle. So I'm making a note right now. We're going to have to label those things with an open circle once we draw our number line. The first thing we do, we ask ourselves, when does the left side equal the right side? The next thing we do, we ask ourselves, when is the left side undefined? Well, I spell it out for you, okay? Since we haven't looked at domains of functions yet, I'm spelling it out. We've seen undefined results in terms of fractions. Remember, we said a number divided by 0 is no, that's undefined. So, to determine when an expression is undefined, you set any denominator, you don't want it to be 0, and solve it for x. These numbers are called denominator or domain cut points, and they'll be denoted with a DCP. If you're going to have denominator cut points, what do you have to have appearing in your problem? If you're going to have denominator cut points, then your problem must contain what? It starts with a D. It's obvious.
Or an F.
Or an F. You're right. What
do you have a denominator? You
must have
must
something undefined. If you're going to have a denominator, you must have what?
Starts with an F.
When we tell you, you're going to feel stupid. You must have a fraction in the problem. There's no fraction in this problem. Look at number 1. Do you see a fraction there? No. So you're never going to have a denominator of 0. So the second step, you might want to make a note here on your paper. You skip that second step if there are no fractions in the problem. If there are no denominators, then you cannot have denominator cut points. You never want a denominator to be 0, so when we do have denominator cut points, you'll see we're always going to label those with open circles. It doesn't matter what the original problem says. Denominator cut points will always be open, and we'll see that later on. But for step 2, I'm going to say skip, because there are no fractions in the inequality. In a moment, we'll see one with a fraction. but not right
Several.
now. We'll see quite a few of them. Step number 3, we're going to draw a number line and label the cut points. We're drawing a number line and we're going to label the cut points. This is a number line, which means it's going to go in numerical order. The only numbers I'm going to write down on that number line are the cut points themselves. We have 2 cut points, 3 and 8. Remember, they have to go small to big. Don't put the 8 over here on the left. You put the small one and then the larger one.
Don't label any other numbers. Only the cut points.
Open circles.
Hey, you
We
wanna go?
said to use open circles because there's no equality on the original problem.
Do you want to put infinities?
Remember, this is an infinity over here. Over here on the left, we have a negative infinity. Step number 4. Select a number in each interval and substitute it into the original inequality. If the inequality is true, shade the interval containing the test value. If the inequality is false, cross out the interval containing the test value. But you're going to have to choose a number in each interval. You're going to choose a number to the left of 3. You're going to choose a number between 3 and 8. And then you're going to choose a number that's bigger than 8. So step number 4. Choose a number. I'm going to choose a number that's in this interval. A number that's smaller than 3. Well, 2 is smaller than 3. But there's another number that's easier to plug in. The easiest number that's
Negative
smaller
20?
than... No.
Oh.
What do y'all think would be easy to plug in for x? We're going to have to plug it into the original problem and see if the left side is greater than the right side. But what number do you think would be easy to plug in? 1 is easy, but there's an easier one. No. 0.
Yeah.
If my interval contains 0, that's what I'm going to test. The only way I wouldn't test 0 is if 0 is not, if 0 is a cut point. You can't test a cut point, but otherwise, 0 isn't a cut point. I'm going to test 0 here. Let's go ahead and identify the numbers we're going to test. What about between 3 and 8? Well, you could use pi, 3.14, but nah, let's use an integer. Let's use something easy. What do y'all think, 5?
Or 4.
Or 4? I'm going to use 5.
6, 7.
I'm going to use, I think I'm going to use 5.
Okay.
Mm-hmm.
Now here it's completely up to you. There's not a, well actually there is.
Could I use 9 in this, over here in the middle? Could I use a 9? Could I use a 9? Is 9 between 3 and 8? No. So I could use 9 over here, but there's another number that's easier to use than 9. We need a number bigger than 8. What do you think?
Not 9, but maybe
10, because it's easy to square 10. We're going to have to,
again,
so I'll
this
say
is just
test 10. Here we go. We're testing, notice how it says, select a number in each interval and substitute it into the original inequality. You're plugging it in right here. Plugging in a 0. You get 0 squared. 0 times 0 is 0, minus 11 times 0. What are we going to get?
11.
Plug in the 0 there. Y'all can do that in your head. What's that going to give us?
11 times 0.
0, okay. And we still have a plus 24. Is that bigger than 0? We have 24 is bigger than 0. True or false? True. If the inequality is true, shade the interval containing the test value. So this is a true statement. So we're going to shade it.
So it's really starting to look like that last example you were doing.
Yeah, it's starting to look sort of like this last, y'all remember this stuff we were doing here? What about between 3 and 8? We're going to test 5. Plugging in 5. 5 squared is 25. Minus 11 times 5. What's 11 times 5? 55, I agree. Plus 24 is greater than 0. Okay. 25 minus 55 is a negative 30. Negative 30 plus 24. What's negative 30 plus 24? Negative 30 plus 24 is negative 6. Is that bigger than 0? No. If the inequality is false at that test value, you cross out the interval containing the test value. So we're now going to cross out. I'm crossing out this middle interval.
It's not a very good pen.
Put it in the cup. Okay, last interval. We're going to plug in 10. 10 squared. What do y'all think's going to happen? Just guess. What do you think's going to? No, let them see.
False.
Let's see if they can. What do y'all think's going to happen over here? If you had to guess, this is a game in Vegas, and you're betting money on it. You think it's going to be true? Let's see. Plug in a 10. 10 squared is 100. Minus 11 times 10 is a 110. Plus 24 is greater than 0. I plugged in 10 squared is 100 minus 11 times 10 is 110. You see how easy it is to multiply by 10? That's why I chose 10 in this interval rather than 9. Plus 24. 100 minus 110, that's a negative 10. Plus 24. What's negative 10 plus 24? 14 is bigger than 0. True or false? True. Shade the interval. I guess that was the longest step of the process so far. Fifth and final step. You know how to finish it off. We have to express the shaded intervals using interval notation. Remember, we square brackets for closed circles, parentheses for open circles, and infinity or negative infinity. So step number 5. Step number 5. We have to write out our solution in interval notation. This interval here, what's the left-hand endpoint? Does this left interval ever stop? It starts going, does it ever stop? So what do we use for the left-hand endpoint? You always put a parenthesis in front of a negative infinity, comma. What's the right-hand endpoint? 3. As I told y'all the last time, there's going to be a union hot button on the toolbar that you'll need to use there.
And also, open circles are always parentheses. You told them that the last time.
I know. Now the second interval, you call it out as if you were typing it in. Don't include the crossed out interval. It's crossed out. It's not part of the solution. So here, parentheses 8, comma, infinity. What do you put after a parenthesis? After an infinity, you put a parenthesis. You only have brackets at closed circles. So right here, as soon as we saw there were no closed circles, you knew there would be no, you weren't going to be typing in any brackets. It would all be parentheses. The parentheses and the brackets you type from the keyboard. So you come over here, parentheses, type the parentheses. Oh, and by the way, we're going to be graphing, drawing an XY grid. Y'all know what I'm talking about? The next time we're going to be begin using our graphing tools. At that point, you'll have ordered pairs. But the thing you're entering, even though it has parentheses, it is not an ordered pair. Don't try to use this hot button. Just type the parentheses from the keyboard. And notice there's no negative infinity. You have to type the negative from the keyboard and then type the infinity. Just like there's not a -5 key on your keyboard, there's just a 5. If you want it to be negative, you have to type the dash yourself.
8, comma, infinity.
Okay, and notice something. You want the symbol that looks like a U, a union. You're saying every number in this interval or in this second interval satisfy the inequality. That symbol there that's upside down, the upside down U is intersection. That's saying every number that's here and in this interval. Are there any numbers that would be common to both of those? There should be no time you're using this, the other symbol, the upside down U. Only use the right side up U.
Yeah.
Any questions there?
Mm-hmm.
Okay, yes.
So he was not sure that when the -6 is the 0, it's not sure what. So when there's negative that isn't sure or something like that.
Yes, write out the words true, false, true.
It was true here. False.
24 is bigger than 0.
False. -6 is not bigger than
bigger.
0. And true there. 14 is bigger than 0.
You shade the true intervals and cross out the ones that are false.
I want to make up an example.
And then we'll
Okay.
discuss how I can look at the problem and decide, oh, it's going to alternate. Because we want to not have to test every one of the intervals. But after we do this example, we'll see if we can figure out a rule. How do we know when it's going to alternate just by looking at it? It's actually pretty easy to tell. Okay? So,
Okay, we're going to follow the instructions.
or
First
not the
thing,
instruction. Well,
we find the solution cut point, replace the inequality with an equal to. Oh, when I look at this problem, what do y'all think? Am I going to have to do step 2? Or will I skip it like in the first problem we did? You'll skip it because there's no fractions in this one either. So step number 1. Set it equal to 0. It's another simple trinomial, so I'll write down my 2 sets of parentheses. X times x gives me the x squared. What do I know about the signs? They're both going to be negative. The second sign's a plus. You have 2 of the first signs. What times what gives 25? It's either 1 times 25 or 5 times 5. Which one's going to do it? 5 times 5, I agree. Oh, this is nice. Set x minus 5 equal to 0. What are we going to get as a solution cut point? Just 5. Do we need to set this one equal to 0 also? No, it's the same thing. You have the same thing inside both sets of parentheses, so you're only getting one cut point there. The cut point is 5. How will we label this cut point? For solution cut points, you must look back at the original problem. For solution cut points, I just have a less than. So what are we going to use? Closed circle or an open circle? We just have a less than. If it's just a less than, what do you use? Open circle. A closed circle means it makes the inequality true. In this case, if you plugged in 5, you'd get 0 is less than 0. Well, no, it isn't. It's equal to. So if it were equal to, then you'd use a closed circle. But there's no equality, so it's another open circle situation. Step number 2, what are we going to do?
Just
Skip it because there's no fractions in the original problem. Oh, we only have one cut point. This is a nice problem. Step number 3. That doesn't happen often where there's only one cut point. Infinity. And the cut point, we said we'd label it with an open circle. Step number 4. Step number 4, we're ready to select a number in each interval and substitute it into the original inequality. I thought substituted into sounded better than plug into the original inequality. We have 2 intervals. We need a number to the left of 5, and we need a number bigger than 5. What do you think I'm going to use to the left of 5? You could have a 4, a 3, a 2, a 1, a 0, a -1. What do you think is the easiest number to plug in? Even if you don't think it's the easiest number, I think it's the easiest number. So what number do you think I'm going to use? 0. You may have a lucky number, like you may have -16 may be your lucky number and you want to use that all the time. Okay, well, I'm going to use 0 whenever I'm able to. Now we need a number bigger than 5. We could use 6, 7, 8, 9, 10. We could use 50 million if we wanted to.
We remember we went to a conference once about making math easy. And it was about using the big
crazy numbers. We're supposed to use crazy numbers. Let's plug in, let's check 2,300,492. And that was making it easier?
We were like, oh my gosh, a lot of people stood up and left during it. I remember that. I just sat there with a smile on my face. Maybe
thinking about where you were going to eat dinner that night.
Yeah.
Okay, what do y'all think I'm going to use to the right of 5? 10 is easy for me to square. That's why I like 10, okay?
I could square. I think I would have just used 6, but I'm good at my multiplication tables. And 6 squared is pretty easy for me.
Plugging in a 0. 0 squared is 0 minus 10 times 0 is 0 plus 25 is less than 0. 25 is less than 0. True or false? False. If the inequality is false, what are we going to do to that interval? Cross it out. Good. Now we're going to plug in 10. Okay. 10 squared is 100.
Well, this is not.
Minus 10 times 10 is 100. Plus 25 is less than 0. 100 minus 100 is 0. Plus 25. We have 25 is less than 0. True or false? False. So look at that. What are we going to do? It's false, so we cross it out. So 5 doesn't check. Nothing to the left of 5 checks. Nothing to the right of 5 checks. This broke that alternating pattern. We didn't. This was false. I bet you a lot of y'all were thinking this was going to be true, right? Yeah, but this one didn't alternate. No interval checks. So in this case, we would have to say that there is no solution. The important thing about this, the reason we made up this problem, is to illustrate one right off that doesn't alternate. Do you understand what I mean by alternating? Alternating is what we had here. Shade, cross out, shade. You don't have a two consecutive true or two consecutive false. Here we have two consecutive false intervals. Why did that happen? There is a fundamental difference between the problem I made up. This problem looks pretty similar to this one. Do you agree? This thing involved perfect squares, though. You got the same thing, x minus 5 times x minus 5. Let's make a note. When we factored in the factoring stage, if you get repeated factors, you better check every interval. Repeated factors, y'all know what I mean by factors, x minus 5, x minus 5. Repeated factors, you expect it to, it may not alternate. You have to check every interval. If you have, I'll say, repeated factors, like the above example, may not alternate. So in that event, check every interval.
If you're a view and example kind of person, they're going to be checking every interval no matter what.
But if you have distinct factors, like here, two different factors, x minus 3, x minus 8, two distinct factors, then I was 100% certain. When I saw that we didn't get repeated factors, I knew. As soon as I saw that this interval was true, I would have bet every cent of money I had in this world that the next one would be false, the following would be true. If there's no repeated factors, I'll say different factors,
like problem
like
one.
number 1. Just check one interval and assume an alternating pattern.
Intervals alternate.
I'll say intervals alternate. I'm a fundamentally lazy person, so I like to check the easiest number possible. What number do y'all think I'll be using to check most frequently? 0. If it's a situation where there's no repeated factors, I'll look and ask myself, where is 0? Oh, it's here. I'll test 0. If it's true, I'll shade it. If it's false, I'll cross it out, and then I'll assume an alternating pattern from there on in.
If you want to test every interval,
Go
okay.
for it. That
It's
is
just gonna-
fine. It's just going to take you a long time, okay? Number 3.
Number 3.
Okay. X times x minus 1 is less than or equal to 20. Oh, this is the first time we've seen a less than or equal to in the problem. Go ahead.
Notice it doesn't say anything about cut points. It just says solve the inequality and write it in interval notation. And
It's up to
giving
you to
this.
know when you're trying to solve an inequality that you're using cut points. That cut point method, what it's saying is, where is the left side equal to the right side? Where is the expression undefined? Anywhere else, it has to either be less than or greater than. And it can't change from less than to greater than without passing through through equal to, or not being a number. So with that in mind, step number 1, replace the inequality with an equal to and solve for x. For a minute, you might think, oh, great, they've already factored the left side for us. They didn't do us any favors here. No, they didn't do us any favors. It's factored on the left, but if it's factored on the left, we need a 0 over here, and we don't have it. So we're going to have to remove the parentheses by distributing x times x is x squared minus x times 1 is just a 1x We need this set equal to 0, so what do you think I'm going to do? So, okay, so that minus 20 equals 0. It's another simple trinomial, x squared. I remember there was a teacher that said they didn't like it because this program could generate any number. Oh, you're not going to wind up with one that has something like 242x squared minus. They have it programmed so that these are not that bad. X squared, just 1x times 1x. Uh-oh, what do we know about the signs? Okay, the last sign's a minus, so you're going to have 1 plus and 1 minus. Now for 20, 1 times 20, I guess I didn't need to write these out. 2 times 10, 4 times 5. Are there any other possibilities? No. Which one will we use? 4 times 5, because you need those numbers to add together to give you, or add or subtract, I'm sorry, to give you that number there. We need a minus 1x. Play it out in your head. To get that minus 1x, what should I put after the plus? The 4 or the 5? The 4 here and the 5 there. I agree. Set each factor equal to 0. So you have x plus 4 equals 0. X minus 5 equals 0. What's my first solution cut point that I'm getting? Negative 4. What's my second solution cut point? Positive 5. I have 2 solution cut points. How am I going to label them on a number line? Look at the original problem. Will I use an open circle or a closed circle? A closed circle. The inequality allows for equality. Negative 4 and positive 5 make the left side equal the right side. Is equality allowed? Yes, that's why we use a closed circle. On number 1, equality wasn't allowed, so you couldn't use those numbers. But if you plug in 5, you're going to get a 5 times 4. Sure enough, that equals 20. If you plug in a negative 4, you're going to get a negative 4 times a negative 5. That also equals a positive 20. Second step, what do we conclude? Skip it. There's no fraction, so we skip. Step number 3. That's where you're drawing your number line and label the cut points. The cut points have to go small to big. Which one am I going to write on the left side? Negative 4, right. And then the positive 5, and those cut points are closed circles. Oh, I didn't even ask this. Are we going to have to check every interval, or can we get by testing only one interval and assuming an alternating pattern? Assume an alternating pattern. Look at where we were factoring right here. You didn't get x plus 4 times x plus 4. You didn't get x minus 5, x minus 5. So you have different factors. That says it's going to alternate. I'll write it out. You don't have to write it out, but I want to make a note. Different factors, so we assume it's going to alternate. Step number 4, it's time to start checking, but we're not going to have to check every interval. We're only going to check one interval. What's my favorite number to check? 0. Which interval contains 0? Interval 1, 2, or 3? Is 0 less than -4? Is 0 between -4 and +5? Or is 0 bigger than 5? I couldn't hear you.
It's in between.
Okay, it's between the negative and the positive. So there's the interval we're testing.
Years ago, I had a student having so much trouble figuring out where was 0, and it finally dawned on me what to say. I told her 0 is always between a negative and a positive. It's never between two negatives. It's never between two positives. I said that. She didn't have any more problems the rest of the semester. She knew where 0 was. And then I made the joke that no one laughed at. So at the end of the semester, when someone asks you, what did you get out of your algebra class? You can tell them, I know how to find 0 on a real number line. And no one laughed. I thought that was a hilarious joke. When I told Tim, he thought it was funny.
Yeah,
No
I
one
did.
else did. Okay, but
Okay, plug it in 0. You test it back in the inequality. So in place of that x, it becomes 0 times 0 minus 1. What's 0 minus 1? No.
give it
0
in
minus
head.
1 is -1 is less than or equal to
Now say 0.
0 times -1. This is where you say 0. You were working ahead of me. You were saying that left side was 0. 0 is less than 20. True or false? True. So shade or cross out? Shade. Come over here. Suppose I tested -5 or -10. Do I expect a shaded or cross out here on the left side? We know it's going to alternate, so we're going to cross this one out. You can go home. If you don't believe me, you go home and you plug in -5. You get -5 times -6. That's a +30 is less than 20. Certainly not. You can check every one of these. It's just not necessary. Suppose we had tested a +6 or a 10 over here. True or false? False. Do y'all understand what I mean about an alternating pattern? Once you knew the middle one was true, the ones beside it had to be the opposite. So
False, true, false.
Fifth and final step. Express the shaded interval using interval notation.
Not the crossed out intervals.
Only the shaded intervals. Call it out as if you were typing it in. I'll get us started. Am I going to type a parenthesis or a bracket? A bracket, because it's closed. Remember, that's the only time you use a bracket is for closed circles. So a bracket, -4, comma, 5. What do I put after that 5? A bracket. This is an interval like this is called a closed interval. It's called a closed interval because both endpoints are closed circles. An interval that's parentheses on either end is called an open interval, but this is the first time we've had a solution that is a closed interval. You can plug in any number between -4 and +5, including the endpoints, -4 and 5. Plug it in up here, the left side is going to be less than 20. You're going to plug in 0.493. Yes, that satisfies the inequality. Any number
Pi
between
is 3.14.
Yeah.
Would that make it true?
pi times pi minus 1, yes, that's going to be less than 20 because pi is between -4 and +5. There you go, using some of those crazy numbers, Tony. So the bracket key, where is that thing? Oh, there it is. It's beside P on a standard keyboard. It's beside the letter P.
What were the things?
-4, comma, 5, right bracket. Any questions there? Number 5. We'll go back to number 4 in a moment, but I want to do number 5
Yeah,
next.
5 is really good.
4x over x plus 2. 4x over x plus 2 is less than or equal to 5.
How does this one differ from the others?
That
Fraction.
fraction, which
Okay.
means, are you going to get to skip step number 2 in our recipe? No, you're not. Okay. Ah. Okay, step number 1. We still start off the same way. Replace the inequality with an equal to and solve for x. So we'll have a 4x over x plus 2 is equal. Look at how I'm writing it. I'm going to write it like that 5, like that. Because what am I about to do with this 5 here? I'm going to write it as 5 over 1. Okay, good. Now, why would I have done that? What am I going to do to solve this equation? Cross multiply. It's a fraction equals a fraction, so we're going to cross multiply. Here we go. Multiply 4x times 1. That's going to give me 4x, okay, equals, you take the 5 times x plus 2. Be careful. What are you going to have to do to multiply x plus 2 by that number 5? Starts with a D. Distribute. Okay, call out what you're going to get. 5x, keep going, plus 10. I agree. I remember back when they would do multiple choice problems. Of course, one of the wrong answers would be what you would get if you went 5x plus 2 and didn't distribute. People would miss that because they'd forget to distribute and they'd choose the wrong answer. Here, fortunately, we don't have that multiple choice hassle. You know what I think? We need to get x by itself. I'm going to subtract 4x from both sides. I'm going to move this 4x over to the right.
So you're saying
Oh, wait a
this
minute. Is this quadratic? Look at what we have here. Is this quadratic? No. So are we going to have to factor? No, which means we're not going to pick up repeated factors, which means it's going to alternate. The only time it's not going to alternate, I guess I could get fancy and talk about even multiplicities, but we don't have to do that. If it's quadratic, and when factoring, you get the same repeated factor, then it's probably not going to alternate, check every interval. But this thing is linear. You're not going to have to factor it, so it's definitely going to alternate, okay? I'd subtract 4x from both sides. 5x minus 4x gives me 1x, okay? What am I going to do with this 10?
isolating the x.
What am I going to do with this 10? Move it over here to give us x equals negative 10. Did y'all follow what I was doing there? I subtracted 4x, 5x minus 4x gave me 1x. I moved that 10 over to the right, to the left by subtracting 10. And that's my solution cut point. I only have one solution cut point. That's good. How am I going to label that number on the number line in a moment? Closed circle. Notice we have a less than. It's the equality that decides it. If you have that little horizontal bar, that's when you use a closed circle for your solution cut point. Second step. You want to know, when is the inequality undefined? And I'm telling you how to determine where it's undefined. Set any denominators not equal to 0 and solve for x. The numbers that you find here are called denominator cut points. When I saw that we had a fraction in the original problem, I knew, we're going to have to check for denominator cut points. There's only one denominator. You don't want that denominator to be 0. X plus 2 shouldn't equal 0, which means x cannot equal what?
Positive or negative?
Positive or negative?
Oh, no, negative.
Negative 2. And This is my denominator cut point. And notice the way it says not equal to. You never want x to equal the denominator cut point, because if you tried to plug in a -2, you get -8 over 0. Remember, a number over 0 is undefined. You don't want that. So the point of this is, for denominator cut points, you don't look back up here. Denominator cut points are always labeled with an open circle. You don't want to shade them in because they don't satisfy the inequality. Denominator cut points will always be open. Remember the little number lines I was making up at the end of class the last time? I have open and closed circles on a number line. That's how it happens. You have a closed circle at at solution cut points, and you only use an open circle at denominator cut points. So you can have both appearing on the same number line. Any questions on my logic there? For denominator cut points, it doesn't matter what the original inequality is. Always label with an open circle. Step number 3, what am I going to do? Draw the number line and label the cut points. Okay, I have 2 cut points. I have -10, and what's the other one? -2. Which one's smaller? Remember, the smaller one needs to go to the left. -10 is smaller than -2. Now, -10, how did I say we would label it? Closed circle, okay. The -2, how will we label it? Always open. It doesn't matter what the original inequality says, denominator cut points are always or never included in the interval. That's why we have an open circle there. Numbers to the left of -2 or to the right of -2 are there, but -2 itself, you are not going to include that. There was no repeated factors, so it's going to alternate. Well, what's my favorite number to test? Which interval contains 0? Interval 1, 2, or 3? Interval 3. 0 is bigger than -2. You could think of it as being between -2 and positive infinity.
See, it can't be between 2 negatives, and over here it can't be between 2 negatives. So which endpoint has a negative and a positive? That's where 0 is.
So plugging in 0. We're going to get 4 times 0 is 0 all over. 0 plus 2 is 2 is less than or equal to 5. What's 0 divided by 2? You have $0 and you're splitting it up over 2 people. How much is everyone getting? 0. Remember, it's okay to have 0 on top. 0 divided by a non-zero constant k, that's okay. That equals 0. It's when you have a number over 0, that says no, that's undefined. So is 0 less than or equal to 5? Is that true or false?
Not equal.
But it's 0 is less than 5. That's true. So shade or cross out. Shade, good. What are we going to do to the interval beside it? Suppose I'd tested -9 or -8 or -3. Would it have been true or false? So shade or cross out. To the left of -10, what will I do? Shade it.
Knowing that it alternates
saves a lot of time. You may not realize it. You may not appreciate it. If so, then I encourage you to check every interval for maybe the first 5 problems in the assignment. You'll see how much time that takes. Unfortunately, what I find happens, people are checking every interval. Oh, here they're checking -7, and they mess up. And then they wind up with a false, false, true situation. If they'd only checked one interval testing 0, they would have gotten that one right and assumed the alternating pattern. You have a less of a chance of messing up if you only test one interval when you're able to do that. And you know when you can do it? When there's no repeated factors. Step number 5, I want y'all to call it out as if you were typing it in. Let's do this interval first. And remember, you have to go left to right, small to big. What am I going to type first, a parenthesis or a bracket? What do you put in front of a negative infinity? You always put a parenthesis in front of a negative infinity. And then what do I have to type? A comma. And what do I put after the negative 10? Right. This is where you put the bracket. That is a closed circle, so you have a bracket. Union, so all the numbers in this interval, or that union can be read just as or. What about the second interval? Parentheses. -2, comma. And what do you always put after a positive infinity? A parenthesis, yes.
You only put brackets at
closed circles, and closed circles can only occur at solution cut points where there's equality in the original problem.
There's one closed circle, there better only be one bracket in your answer. Okay? Tim, do you want to tell them the first time we ever did these, our teacher had a method. Do you want to tell them what it was?
Think about it. Think about it. Just think about it. Just think about it. Just think your way through it. This woman was brilliant, a PhD, but she could just think about it and see these answers, okay? Oh, imagine sitting out there as a student and I'm just telling you, think about it. Let's just analyze this stuff and think about it. Well, she had what? 6 years, a master's and a PhD of graduate analysis. So thinking about it, that's fine. But as a freshman sitting out there, what do you mean think about it?
How do you think about it? The first time I ever saw this sequence of steps, I was like, oh my gosh. Why did it? Back then we had these paper books, and you never opened them unless looking at a homework problem or something. I was like, why didn't I look through that paper book?
No, I saw this stuff, okay, the first time, and I rushed over to Tony's office. We were teaching, okay, at Baylor University. I saw this sequence of steps. I was like, what is this? The students, I was like, we're just going to think our way through this. Let's just think our way through it. And then Tony was like, no, you got to use that recipe. It's so easy.
It works. I had a coworker years ago telling me, wow, that cut point method, I love it. I don't know why it works, but it works. And
Dr. Hoyt, I remember Dr. Hoyt. He didn't know why it worked, but it worked. I'm like,
oh gosh.
Just think about why it works. Every number, if you're thinking about real numbers, it's either going to be equal or undefined. Every other number is either less than or greater than, and you can't change. Think about going from small to big. You can't just go on the number line. You have the negative numbers, you have the positive numbers. What's right there in the middle? You can't skip over that. 0. So it either has to be equal to, or not a number. But either way, did you type it in, type in the answer? Tony, my screen was going dark the last time.
Because you were probably talking too much.
No, it was absolute value equations.
Oh, but you want to do 4 before 6?
Yes.
Let's go back to number 4.
Oh, goodness. I don't like that problem.
Too many negative ones.
I know. Okay, wait. We're going to think about it. Y'all are going to answer some questions for me.
Oh, you're just going to start going through the
No, I'm going to have. Will your number line have any closed circles? Will you have closed circles on your number line? Yes? It's one of those. I heard yes and I heard no. It's one of those.
No, because
In
it's
order
not-
to have closed circles, what sort of inequality do you have to, what do you have to have here underneath that little, you have to have a line there for equality. Since there's no equality bar, there's not going to be any closed circles. Okay? Will your interval notation have any rectangular brackets?
will there be any brackets in our answer? There's not any closed circles, so
No, there's not going to be any brackets. That means your interval notation, what's the grouping symbol that's going to have, the only thing you're going to be using? Parentheses. Okay. So there, we thought about it. It didn't give us a solution, but we thought about it. We have an idea of what our solution should look like at the end. Let's switch over to the paper. Negative 1 over x minus 1 is equal to negative 1. And notice how I wrote that equals a negative 1, because what do you think I'm about to do with this thing? Put it over 1, and then cross multiply. You see how often you can set up these equations with fractions as proportions? You don't have to think about common denominators. Just set it up as a fraction equals a fraction. Here we go. Negative 1 times positive 1, what's that going to give me? Negative 1 equals,
don't forget to distribute here. What are we
you're going to
have?
take negative 1 times x minus 1. You know, maybe I better write that down. There.
You sort of defeated it.
Negative 1 times 1 gave me a negative 1. And now we're going to take this negative 1 and multiply it by x minus 1.
My students.
Then what will that give me? Okay. Hey, are we going to have to get this set equal to 0 and factor? If it's not going to alternate, if it's one that won't alternate, then you're going to have some x squares appearing. Do you see any x squares appearing? No, this is linear. So is this going to alternate? I think it will alternate, okay? We're not going to have to check every one of the intervals. Let's move this minus. We need to solve for x. I'm going to pick that minus x up and move it to the left. Why am I doing that?
Make it
A positive x equals, what am I going to do with this negative 1 here? Add it. Negative 1 plus 1, what have we got here as our solution cut point? 2 as our solution cut point. And for solution cut points, how do you decide whether it's open or closed?
based on the sign.
Okay, so I look up there, I don't see a horizontal bar, so
It's open.
open, okay. Oh yeah, we'd already gone through that discussion, hadn't we? There's not going to be any closed circles. Second step. Can I skip the second step? No, because I see a denominator. When I saw the problem, I knew I'm going to have to do that second step. X minus 1, you don't want it to be 0. So x cannot equal 1. That's my denominator cut point, and it doesn't matter what that symbol is there. Denominator cut points you never want to include in an interval. You never want to include them as part of the answer. So denominator cut points are always labeled with an open circle. What do we do next? Draw the number line. Here's step number 3. I'm going to draw my number line. We have an infinity. We have a negative infinity. We have 2 numbers. We have 2 and 1. Which one am I going to write here? 1. Remember, they got to go in numerical order. They're both open. Don't put 2 and then 1. Step number 4. What do? Test. I agree. We're going to test. What number do you think I'm going to test? I could hear you. Zero. Which interval contains zero? Interval 1, 2, or 3? Now realize if you were testing every interval, this would be sort of crappy because you have to choose a number between 1 and 2. I guess you could use 1.5, but there's no integer between 1 and 2. So I sure am glad that we know that this is going to alternate. So we only have to test one interval. Let's test 0.
Notice it's between a negative and a positive.
0 is located between the negative infinity and positive 1. That's going to give me a negative 1 all over. 0 minus 1 is another negative 1. Is that bigger than negative 1? What's negative 1 divided by negative 1? No.
Division.
1, okay.
Division.
You never get the you never say anything wrong. But any future teachers here? Okay, here's a good teaching tip. The student that never says anything wrong, the one time she says something wrong, you pounce.
And
Okay,
that's bad
That's
teaching.
bad teaching. Okay, you don't want to do that. Negative
division.
divided by negative is a positive
Positive
1.
one.
Is that greater than negative 1? Yes, so that's a true statement. So shade or cross out. Shade, I agree. What am I going to do between 1 and 2? If I had tested 1.5 and got it done correctly, would I expect it to be true or false? False. I'd cross it out. If I tested 3 over here, or 30 million, true or false? True. So shade. Okay, we need to write it in the fifth and final step. Express the shaded intervals using interval notation. So here we go. I'm going to let y'all call it out as if you were typing it in. What would you type first? A parentheses, and then negative infinity is the left hand is on the left hand side. Oops, I put the comma automatically. So
Comma
1. What?
parentheses,
Okay. Or
comma, I mean not comma, parentheses,
parentheses
2,
2.
comma, positive infinity, and then parentheses.
Okay.
I want to see y'all think about that and get the answer. Wow. Oops, let me type that in. Parentheses, negative infinity.
And once again, there's not a negative infinity hot button, just a plain infinity. So to get a negative infinity, you have to type the negative sign from your keyboard and then the infinity symbol.
Okay. So let's see, we've done 5. 6 is the next one.
6, yes.
Now 6, you're going to see what happens when 0 is a cut point.
Then you're going to have to choose another number, and I'll ask you, okay, what's the second easiest number to plug in? 0's the easiest, but if you can't plug in 0, what do you think you'll use? Just be thinking about that. That says z over z minus 7 is greater than or equal to 2z. Okay. Z over z minus 7 is greater than or equal to 2z. Do you remember how the people would put crosses through the z's at Sears when Monica worked there? And she didn't know what was going on.
Yeah.
What were they doing writing like that? Yeah. That's why you put a horizontal slash through that z to try to make it not look like a 2.
But then there's this thing here. I always thought that was...
No, that says 2 right there. My perfect 2 that I write there. Oh, goodness. Okay, first step, what am I going to do? I'm not even going to put the
Oh, wait,
sequence
let's
of
analyze
steps.
it first. Will there be denominator cut points? Will
Yes,
there be some closed circles?
yes,
Will there
because
be square brackets? Yeah.
will there be open circles on the number line?
Wait,
Yes,
because
because
always,
remember, denominator cut points, it doesn't matter this thing here. Denominator cut points always open. You never want a denominator of 0. So for the so this time we're going to have both. We'll have the closed circles from the solution cut points, and we'll have the open circle from denominator
let's just go
cut
one
points.
step at a time. I'm not
Okay.
jumping around.
You wanted to think about it though. Step number 1, what am I going to do? What's the first step in this recipe? Make it equal to. Okay, that's right. Z over Z minus 7 is equal to 2Z. And what do you think I'm going to do with that 2Z on the left side? Put it over 1, okay. And cross multiply, good. Z times 1 gives me just Z, okay, equals 2Z times Z minus 7. What am I going to have to do there? Distribute. So I'll get us started. 2Z times Z is 2Z squared minus 2Z times that 7. That's how I got that minus 14Z. Uh-oh, it's quadratic. That means we need to get it set equal to 0 and solve. But this isn't going to be a trinomial. I'm not going to pick up that 2Z squared and move it to the left, though, because if I did, what would happen? It would become a negative 2. So I'm going to subtract the Z from both sides. Minus 1Z minus 1Z. So we have 0 equals, we have a 2Z squared, and what else do we have? Minus negative 14 minus 1 is a minus 15Z.
Perfect.
And this is not a trinomial. You're not going to factor it by trial and error. Instead of reversing the FOIL method, we're going to reverse the distributive method. The distributive property. We're going to reverse the distributive property.
You don't have that constant there.
You don't have that constant. This is the first time I think we've run into this. What's common to both terms? I couldn't hear you. There's some character that's common on both of those. They both have a Z, so we're going to factor out a Z.
So what you're doing is called factoring out a variable.
Factoring out a variable factor.
Oh.
You had 2 Z's in this first thing. You took out one of them, so you still have the number 2 and what else? A Z minus. Here you had a 15 and a Z. You took out the Z, so you just have a 15.
So it's easier to factor these like this than trial and error.
Yeah.
But
that's why you don't have that many before you do this. Okay?
But it gets a little tricky right now. You now set each factor equal to 0, including.
That Z right there is a factor. You have to set that monomial factor Z equal to 0. So there's one of our solution cut points. It's already solved for Z. Then you set 2Z minus 15 equal to 0. 0 is one of our solution cut points because we set the common factor Z equal to 0. There's no work to solve there. Here, what am I going to have to do to get Z by itself? Move the 15 to give us 2Z is equal to 15, and then divide by 2 to give us Z equals 15 over 2. We have two solution cut points, 0 and 15 over 2.
Well, we put
How are we going to label these solution cut points? Open circles or closed circles?
close.
Because for solution cut points, you have to look back at the original inequality. If there's equality, that's when you use a closed. So you're going to have a closed circle at 0. You're going to have a closed circle at 15 over 2.
Years ago, a student told me this is how she remembers
Is it vulgar?
this. No.
Oh, okay.
Whether the closed circle and open, she thinks, okay. Looking at the two symbols, what uses more ink to write? The one without the equal sign or with it?
Oh, actually, that's a
With
good
it.
way of remembering.
What has more ink?
An
Open circle or a closed circle? What are you going to use more ink on? The closed circle.
Okay, yeah. Okay.
The open circle uses less ink, and so does just the plain greater than or less than. The symbols that use more ink use the circle that uses more ink. And that was her suggestion. I said, I'm going to remember that. And we're talking about, I think it was 2004. Oh
Very
my gosh.
good year, I
Yeah.
might add.
Oh wow. How many? Oh, what is that? 21 years ago. And
Wow.
I'm still remembering her little
Wow.
suggestion.
Any questions? We found two solution cut points, 0 and 15 over 2. Next step, denominator cut points. Are we going to have any? Yes, because we have a denominator. And this is a short step, so notice I'm going to separate this, and I'm going to do the second step right here. You take the denominator that you see, the only one you see is z minus 7. That cannot equal 0. So z cannot equal 7. That's my denominator cut point. And how do I always label denominator cut points? Open circles.
In fact, write the word always in front of that 0. I mean the open circle.
Always open circle. That looks like always so, if you think of it. Or maybe I'll make this a thread or something.
No, that was a bad suggestion on my part to write the always.
Okay, there.
Okay.
Third step. Oh yeah, I wasn't going to be referring to the steps. I was going to see if y'all knew them. Step number 3. Draw the number line, okay. Oh no, that's a negative infinity. We have an infinity. And how many numbers do I have to label on here? 3, I agree. 1, 2, 3.
Make
have-
sure you put them in numerical order.
So 0, 15 halves, and 7. What's the smallest one? 0. Next, is it 15 halves or 7?
Think of the 15 halves as a mixed number.
How many times does 2 go into 15?
7.
7 times, okay. And a remainder of 1. So that's 7 and a half. Or you could put it in your calculator and get 7.5. What's the bigger? What's bigger, 7 or 7.5? 7.5. So put the 15 halves. That's the biggest one, and then the 7.
No.
You've got to arrange those numbers in numerical order, small to big. Now let's label. How am I going to label 0? Open or closed? Closed. 7. Open or closed? Open. 15 halves? Closed. Remember the last time I said you'd have open and closed circles on the same number line sometimes, and we certainly have that. Step number 4. Oh, by the way, we had to factor, but did we get the same factor same thing inside the parentheses.
Are there any repeated factors? Is it going to alternate or not? It's going to alternate. There's no repeated factors.
Here's something else. Look back at that one that I made up. 25 is a perfect square. You have to have perfect squares appearing in the problem in order to wind up with those same factors. 15 isn't a perfect square. 2 is not a perfect square. So to get those repeated factors, you would have to have perfect squares appearing in the problem, which we don't. Our two separate factors of z and 2z minus 15, they're different factors, so we're going to assume an alternating pattern.
If we were in
Can
Vegas,
I test 0? Oh,
if we were in Vegas and this was a gambling game, you had to bet whether something alternated or not. If you don't know, guess alternate. Okay? I mean, it's going to alternate more than not alternate.
Correct.
Okay? Because it takes some effort to make up the ones that don't alternate.
Step number 4. We got a test. Can I test 0? No, because 0 is a cut point. So I can't test 0. What's another number that's real easy to plug in? Maybe something close to 0. 1. You could use -1, but I try to use as few negatives as possible because students mess up more with the negatives. Which interval contains 1? Interval 1, 2, 3, or 4? 2. So right here, this interval is the one we're testing. We're going to test 1. You could test 2. You could test 3. You could test pi, but use something that's easy between 0 and 7. I thought 1 was easy to plug in. So we have a 1 over 10 isn't between 0 and 7.
No, but way over here.
Oh, yeah.
Moving the cursor over here. Testing this last interval with something like 10, I think that'd be pretty easy.
Testing 1. We get 1 over 1 minus 7. What's that going to give me here? Plugging in a 1. You plugged in the 1 there. -6 is greater than or equal to 2 times 1. Replace that 1 with that z with the 1. 2 times 1 is? Okay. So positive divided by negative is negative. We have a -1/6 is bigger than 2. True or false?
Is a negative number ever bigger than a positive number?
No, so that's false. So what do we do here? Cross out. If we had tested a number over here, what would we expect to do? Shade or cross out?
What, shade?
Shade, remember it's got alternating patterns.
So, true.
True. False. Here. True. And it's a good thing we have that alternating pattern. Otherwise, that's 7, that's 7.5. You would have had to use something like a 7.1 or a 7.2.
I guess maybe with their calculator.
Yeah, with the calculator, that doesn't. I guess that wouldn't be a hassle. So what about over to the right of 15 halves? Shade or cross out? Cross out. Oh, okay. So there. Fifth and final step. What do we have to do? Write it out in interval notation, going from left to right. Call it out as if you were typing it in. What would you type first? Parentheses, negative, infinity, comma, 0, bracket, U. And that doesn't come from, that's not a U from the keyboard, okay? That is from the toolbar, the U symbol from the toolbar. Okay, the next interval, what am I going to type first? Parentheses, 7, comma, 15 over 2. And what's going to go after the 15 over 2? The bracket.
I want to see you just think about it and get that answer. Yeah. Really, it's a great sequence of steps. Yeah, it's long. Yeah. But it could be worse.
It could be worse.
Okay, let me start typing that in. Parentheses, negative, infinity, comma, zero, bracket, union, parentheses, 7, comma, 15/2, bracket. I remember the time this, ooh, wait, where'd I get that 7? What the heck is that? Look at that. Oh, wow, I really messed
you really
up.
messed that up, didn't you?
Okay, 7, comma, 15/2. I
You were
remember the
never very
time.
good with computers.
Yeah,
were
I
you?
remember once a student
not-
telling me, sending me a screenshot that it counted their answer wrong and they know it's right. And it was like this.
What's wrong there?
The brackets in the between.
Yeah,
That's
and
right.
does it know what it's doing? If you're a viewing example type of person, oh, watch out. They do everything without ever mentioning,
Cut points. Well, they're calling them test points.
no,
No.
that's the test points, not
Oh,
the
you're
cut
right.
points.
The test point is.
They don't
the
ever say cut points. They're just sort of values. Well, I think you need a name to refer to them
Okay,
by.
go ahead, Tony.
Whoop. Right arrow bracket. Now that's going to get it right.
Okay, number
Let's get to-
9.
Let's do something y'all did the last time. This is not a 15x plus 51. Y'all see what those are?
Look at this. That's why we solved those absolute value equations the last time, getting you ready for the absolute value inequalities today. Because the first thing you're going to have to do is get rid of that inequality and write it as an equation. And just like I did the last time, I'll try to put the absolute values into a different color. The absolute value of 5x plus 15.
No, plus 5.
Oh, well, shoot. Number 9, the absolute value of 5x plus 5 minus 13 is less than negative 3. There's something I don't like about this
Well,
problem.
first of all, how do you know you're going to do cut points?
What tells you that you're going to use cut points on this
Because the
problem?
instructions don't say it. They just say solve the inequality.
How do you, because of the inequality. That's it. That's how we're solving inequalities this semester. It's the only way we're going to solve inequalities is through the use of cut
You
points.
see a less
Now,
than or greater
look at
than?
recall what we said the last time. There's something here that I don't like about this number 9. What do you think I don't like about this number 9?
What about the,
I couldn't hear you. Okay, we do not want, remember, whether it's equations or an inequality, we need the absolute value by itself. Remember I said, if you have anything else being done to that absolute value before you do anything else, you got to isolate that absolute value. And, oh, where was it? I think we had a problem like that. If I'm,
Well, I
oh,
sure
here's
hope
one
so.
right here. Right off. If you have something added to or subtracted from that absolute value, you need to isolate the absolute value expression
I wanted
first.
to make sure you'd written it out
Yeah.
in words.
You must isolate the absolute value before deciding. I said before deciding how many solutions you'll have. I should have said before you do anything else when working with absolute values. So before I do anything else, I'm going to get this absolute value by itself by moving that 13 over, adding 13 to both sides. We're going to get the absolute value of 5x plus 5 is less than, what am I going to have over here?
10.
Negative 3 plus 13
13.
gives me a positive 10. And once you do that, once you've isolated that absolute value by undoing any addition or subtraction that's over there, I highly recommend You mark that original problem out and never look back at it. Added 13 to both sides and got the absolute value isolated. And now treat this problem as if this were the problem you were given.
Hey, let's continue with the analyzing. Are there going to be any denominator cut points here? No, there's no fractions.
Are there going to be any, do you expect to get any closed circles on your number line? No, because there's no equality. So,
even though it looks different because of the absolute value bars.
This is the easiest one we've done so far.
Yeah.
First step, replace the inequality with an equal to. So here's step number 1. We have the absolute value of 5x plus 5. Make that equal to 10. You have to remember what we were doing on Monday. Yeah, how many solutions do we expect to have here? In order for this absolute value to equal 10, the stuff inside here must equal 10 or negative 10. It's like what we had. I can't tell if y'all are following or remembering what we did the last time or not. Let's see here. We got it by itself, and then you had an absolute value equaling a positive number, which meant 2 solutions. You set the 5x plus 5 equal to positive 10, or 5x plus 5 equals a negative 10.
So to solve an absolute
y'all remember
value
doing that the last time? Yes. So what am I going to do here? Subtract the 5 from both sides to give us 5x equals 5. 10 minus 5 is 5. And then divide by 5 to give us x equals 1.
So the formal name for this is your equal positive, equal negative. That's my formal name that I've invented that I'm sure Tim didn't mention on Monday.
Of course I didn't. Okay. Now this one. For our second solution cut point, what will I do first? Subtract the 5 again to give us 5x equals negative 10 minus 5 is negative 15, and then divide by 5. So we're getting a second solution cut point of negative 3. I agree. And these are my solution cut points. I have 2 solution cut points. Open or closed? Open because there's no equality in the original inequality. Second step, skip. Third step, draw your number line. You know, the vocal minorities sure have gotten the hang of this. Y'all are the vocal minority. Most people just sit there, don't say anything, but there's that minority that says stuff. And that minority has the hang of this.
When you were a
stuff,
student, Tim, what were you?
I just sat there willing myself to invisibility using my
So you were not in the vocal majority.
Oh, of course not.
As a student.
No. Okay, I'm waiting for y'all to tell me what's going to be written first, right here. The negative 3. You laugh, but you'd be surprised who would do. People go 1 and then negative 3, and then they wind up with the numbers reversed on the number line. I mean the interval notation, and it's all marked wrong. Open. Hey, did we have to factor? Did we get any repeated factors?
No.
No. So we only have to test one interval. What number do you think I'll use as the test value? The last time, that other one, I wasn't able to use 0. Can I use 0 here?
No. Oh, wait, yes.
Yes, because 0 is not a cut point. The only time I'm not going to use 0 is when 0 itself is a cut point. Otherwise, I'm going to test 0. Which interval contains 0? Interval 1, 2, or 3?
2.
Yes, it's between -3 and +1. I'm going to test 0, and that's going to give me the absolute value. Oh, by the way, you're testing in the rewritten form. Testing in the original, people always mess up. So test in the easier format, the one where you've isolated the absolute value. Plug in the 0. You get 5 times 0, which is
0.
plus 5 is 5. So you have the absolute value of 5 is less than 10. What's the absolute value of 5?
5.
Is 5 less than 10?
Yes.
So that's true. So shade. Here, cross out. Here, fifth and final step, interval notation. Am I too low? I can push it. No, I guess I'm okay. Call it out as if you were typing it in. Parenthesis. Okay, good. Tony, you ready to take over?
Sure.
Okay.
Well, let me turn on my microphone. You turn yours off.
Mm-hmm.
Okay, you gonna type that one in?
Mm-hmm.
Yeah. Okay.
So sometimes students say, well, why on this one do you do equal positive, equal negative? And then they'll go back to the other problems and start trying to do equal positive, equal negative on these. No, no, no.
What does that problem have that the others didn't
I
have?
can't see it.
Number 9. What does that problem have appearing in it? Why did you do the equals positive and equal negative? The absolute value bars.
So y'all, Tim, which one are you doing next? Or do you want me to do next?
8.
Okay, and y'all tell me if it's going to be equal positive or equal negative and how you know. But I got to see the problem.
I'll show it to you when I'm ready to, Tony.
Oh, Tim, you're never good with the mouse. What do y'all think? Is this going to be an equal positive and equal negative?
Yes, because it has those absolute value bars. This is actually easier than number 9.
So it's an absolute value. Hey, are we going to have any denominator cut points? No, there's no fractions there. Is greater than 10. Absolute value of 9 minus 4x is greater than 10. Notice those instructions. It doesn't say anything about cut points. How do you know you got to follow these 5 steps?
That greater than inequality, the fact that a greater than appears in the problem.
So on this one, the absolute values are already isolated. So we go straight off. Step 1, finding those solution cut points.
Oh, wait, I better switch you over.
The absolute value of 9 minus 4x is greater than 10.
And notice the absolute value is already isolated. You don't have to move any terms around.
So we can go straight to 9 minus 4x equals positive 10, or 9 minus 4x equals what? Negative 10. Okay. Hey, are we going to have any square brackets in this one? Nope, not an equal sign there. Okay, so this is just a linear equation. There's no x squared, so no factoring. Let's just isolate the x. Here's what I think I'll do. I'll move the 9 over. So we have negative 4x equals 10 minus 9. Am I going to put a 1 right there? And then what? Divide both sides by negative 4. So we have x equals negative 1 over 4. Okay, well, might not be a pretty cut point,
By that I mean, I like it when the cut points are just positive numbers. I'm not so keen on them when they're negative or fractions, but okay. Negative and fraction, but we can handle it. Let's see, over here, I'll do the same thing. I'll subtract that 9, but be careful. Negative 10 minus 9, that's a negative 19. Then what do I do? Divide both sides by negative 4, but at least if we're going to have two fractions, one of them's negative, what's the other one going to be? Positive. Why do I seem to think that's a good thing? It should make labeling them easier. You should know that the negative one is the smaller one. I always like a negative cut point and a positive cut point. If I can't just have two positive integer cut points, one negative, one positive. Hey, now what about our denominator cut points? Did we have any of those? Nah, there are no denominator cut points, so we'll skip that. So step 3, we draw our number line. Negative infinity, infinity. I'll put my 2 marks. You know what? I don't think I labeled, or I should have asked y'all this. For these are the solution cut points. Look up here. What did we decide? Open or close? Or what do you know? Open or close circles? Open. So open circles. The negative 1 over 4. The negative number is always smaller when you have a negative and a positive. That's why I said at least it was, even though we had to have two fractions, at least one's negative and one's positive. You know how to label them easier. Step 4. Am I going too fast? Y'all caught up? Which number do y'all think I'm going to test, assuming I'm just like my brother? 0. 0 is where? Between two negatives? Between a negative and a positive? Or between two positives? Between a negative and a positive. So again, when someone asks, what did you learn? You can tell them you can find 0 on a number line, and that is a really funny joke that no one ever
That's
gets.
a mathematical joke.
If that's all you got out of this class is being able to find 0 on a number
It
line.
sounds better when you say locate 0 on a real number line.
You think so?
Yeah, locate
find
sounds
it.
fancy.
You're searching for it. Okay, now we're going to plug in 0 into the original problem. 9 minus 4 times 0. That's just going to be 9. All right, 9 minus. Now, what is the absolute value of 9? Before you decide true or false. Oops. Yeah, just 9. So we have 9 is greater than 10. True or false? False. So this one's false. Cross it out. And what about the other two? Shade them in. Shade, shade. And then y'all want to call out the answer. I'm pressing my brother. Okay, parentheses, negative infinity, comma, negative 1 over 4, parentheses or bracket, union. I remember we used to not say cross out. We just shaded, and the ones that we weren't shading, we just left them there. And then I started noticing students were just listing all of every interval as an answer. And then Tim said, tell them to cross it out. Let's try that and see if, hopefully the fact there's a big X here means that's not right. That's why we say put an X there. So union, parentheses, 19 over 4, comma, infinity, close parentheses. I wonder what's going on. Was this happening the other day?
Yeah.
Oh, so, what did I think I was, so, now I'm going to type it in. This means all numbers to the left of -1/4, not including 1/4. And also the numbers, oh, where'd that come from? Well, I'll let you type it in. You get to type in a mess thing.
Okay.
Let's see if he knows how to. Help him out. Do you need trouble, help with the mouse, Tim?
Parentheses, negative infinity. There's a point, something I need to tell y'all about this. I should have told y'all a long time ago.
You went right arrow to not put it down there in the denominator, the parentheses. No, 19
Oh,
over
19 over 4. Okay, 19 over 4.
No, you put 18
Oh
over
my
4.
goodness.
He was never good with computers, let me tell you. Trying to say something that my 90-something-year-old mother would say, and I would laugh.
Okay, I need to look back at the work. Notice how I never label the test value. Tony doesn't either. When we're drawing our number line, we don't label the test values on the actual number line. The only numbers we label on the number line are the cut points themselves. Those are the numbers that will appear in the answer, okay? Like you tested a 0. Did you have to type a 0 when using interval notation? No. What we have found is that the students that do stuff like this, oh, I'm gonna test 0, and they label it, all of a sudden they wind up with things like -3, 0. They start typing the test value into the interval notation. And no, the only numbers, the only characters that can appear in your answers are
Cut point.
cut points, infinity, negative infinity. The test values themselves, you do not wind up typing in. As a result, you'll notice he didn't put a little mark and say zeros right there and label it on there, because that leads to people typing in that as part of the answer when it isn't. Although it's included in the answer. No, it isn't. 0 is not included in the answer. It's not in either of those intervals. But that's a point we should have made earlier, and we didn't. Number 11.
Okay.
Hold on.
Number 11.
Oh, yeah, this is a long assignment, but I think it's better than the radical and rational stuff. At least students seem to think that it's better, or not quite as painful as the radical and rational equations.
Absolute value of x squared plus 2x minus 25 is greater than 10. Any denominator cut points on this one? No. So we'll get to skip step 2.
Tell me in words, what's the first thing he's going to do? Well, before that, I mean, you're right, we're going to wind up factoring, make it equal, okay? Look back at the last thing we did. No, you weren't here, Tony. Look, let's go back. So we're going to have the absolute value of that stuff equaling 10. That's going to be the first step, correct? Let's see, keep going before this. Goodness. Isn't this what, I was trying to get us ready for that. The last time I made up this example towards the end of class, so that we had a quadratic absolute value equation, it was trying to get us ready for the quadratic absolute value inequalities.
And so you set it equal positive, equal negative. That's going to be the first step for finding the solution cut points. It just so happened that the one I just did has a 10 greater than 10. Number 8 had greater than 10, and so does this one. but you still set it out the same way. Equals positive 10 equals negative 10. I'm going to have to write smaller.
Oh, that was hard for me the last time. I had to write small, getting both of those things there. I'd write.
Mhm. And then, you know what? I think I'll do a different color.
Here, this is a good.
Is it? Okay. Equal negative. X squared plus 2x minus 25 equals negative 10. So we're going equal positive 10 equals negative 10. Very much like the one we just did. The only difference is problem 8 is linear and problem 11 is what? Starts with a Q. Quadratic. We're solving quadratic absolute value inequalities. Now, okay, start off, we need a 0 because it's quadratic. There's that x squared. So I'm going to go ahead and subtract 10 from both sides. So we have x squared plus 2x. Is that going to be a minus 35? Equals 0. Or if you just want to say you move the 10 over, either way you're subtracting 10. Because the fact it's quadratic, we need to factor it. So x and x. 1 times 35 or 5 times 7. What do y'all think is going to work here? Aren't those only pairs for 35? Oh, y'all are wanting me to ask about the signs. What sort of signs are we going to have in here? 2 pluses, 2 minuses, or 1 of each? One of each. The second sign is negative, so 1 of each sign. I guess I'll do like my brother and put plus and minus, although my habit is to sort of wait. And now, what did y'all say? 1 times 35 or 5 times 7? 5
With a
times
simple
7.
trinomial, you choose the pair that adds or subtracts. In this case, it subtracts to give you that number there. 7 minus 5 gives you 2.
So a positive 2. So what goes with the plus? The 5 or the 7? 7. Good. And 5. This factoring is going to stay with us really through every math class except statistics.
Until you get into topology or.
Oh, yeah. Okay. Now set each one of these equal to 0. We're going to have a lot of cut points here. And we get x equals, is the first one negative 7? And when I set x minus 5 to 0, a positive 5. I didn't ask, I don't think, and I should have opened or closed circles for these solution cut points. Open. But we've only found 2 of our cut points. We have more right here. So,
do y'all remember doing this problem at the end of class last time? Okay.
Add 10 to both sides, or move the 10 over, whatever you want to call it. Negative 25 plus 10 is a negative 15. This programmer, whoever wrote the code for this problem, was a genius because it always works out so nice, the things that factor nicely.
X squared, x times x.
Okay.
Signs.
That's the second sign was a minus. Can y'all tell that's a minus? It just looks like a big smudge to me.
It's a smudge.
Okay. 1 times 15 or 3 times 5? 3 times 5. What goes in front of the plus?
After the plus.
Excuse me, after the plus. I said it right. Yeah, 5, 3. Then set each one of these equal to 0. And we get x equals a negative 5.
And what else?
X equals +3.
X equals +3. Hey, I should have asked. Did we have any repeated factors?
No.
No, this thing's going to alternate.
Even though you have 4 solution cut points, you're only going to have to test one interval. And so, regardless of how messy this looks, go back and remind them again. Show them that what you just did, they did the last time. I used that exact same problem. There it is. I suppose mine was a little written a little neater than yours, but
You can't
as a
all win the
penmanship award, multiple penmanship award winner, it's, I have an unfair advantage. I just have better penmanship.
Okay.
I think that word's archaic. Does anyone use the word penmanship anymore? I don't think so. Do they give penmanship awards in school?
What about, I was watching this old episode of Psych, and they were talking about the spelling
No,
bees.
you got to do some more.
Oh, shoot. Oh,
Just
wow.
squeeze in. So
Yeah, I need that's not a good number line.
it's okay.
Because there's 4.
Just put it. No.
I'm just going to agree to it.
Oh, okay.
I don't want a messy thing. You're okay with messy.
No, I'm not.
Negative infinity, infinity. I've got to label all 4 of these cut points in numerical order.
And you'll notice we don't try, this interval's long, we got to leave a lot of space. I just spread those things out, usually equidistant.
So looking at these 4 cut points, I'm going to start here. Y'all call them out in numerical order. What do I put first?
-7.
-7, then
-5.
-5.
-7, -5. And what's the next
Positive
one?
3.
Okay. And they're all open circles.
If you're a view and example type of person, I'd recommend against it.
For these absolute value quadratic inequalities, I strongly recommend you do it our way. We'll look at that later on. What's that?
Or they can look at it, But
What number do you think we're going to test? Which
There's really
interval
only 4
contains
numbers I
0?
can't
1,
test.
2, 3, 4, 5. Which interval contains 0? 3. It's between -5 and +3.
I'm going to use red to test it. So here's the one I'm testing. I'll either get true or false.
Oh, I don't even see the problem. You're going to have to move it down so we can see
Oh.
the inequality.
Greater than 10.
So testing 0.
Plugging a 0 in. So we have 0 squared is 0. 2 times 0 is 0. So we have 0 plus 0 minus 25. Now here's the tricky part. Don't
Be careful.
decide on true or false until you actually take the absolute value. It isn't -25 is greater than 10. That would be false. But wait, take the absolute value of -25. What's the absolute value of -25?
No, it's a
Not -25, it's
positive 25.
You
How
act-
many units away from -25 is it to 0? How many units apart are they? 25. Remember that absolute value of -25 is actually a positive 25. And now,
See, look, right here, you went absolute value of 5 is 5, and you wrote it without the absolute value bars. Well, the fact that it was a positive number inside here, like I messed up. 9 minus 0 is 9. The absolute value of 9 is still just 9. But the difference here, the absolute value of -25, that's 25. So now that we have it like this, 25 is greater than 10, true or false? True. So that means
shade.
Now just go through alternating. This would have to be false. True. Right here. False and true.
So we're going to have 3 intervals as our answer, but fine. That just means we're going to have 2 of those U symbols. We're not going to have any brackets, so we're no closed circles. So to get started, we'll say parentheses, negative infinity, comma, -7, parentheses, or little union symbol. What about the next one? Parentheses, -5, 3, parentheses, union, parentheses, +5, comma, infinity, parentheses. So negative infinity to -7, union -5 to 3. What this is saying, what numbers can we plug in for x and get bigger than 7?
Bigger than 10.
Bigger than 10, I mean? Well, any number to the left of -7, not including -7. Any number between -5 and 3, not including -5 and not including 3. Any number bigger than 5, not including 5. Or if you want to say any number between 5 and infinity, not including 5 and not including infinity.
Let's type in our answers, parentheses, negative infinity, comma, -7, right parenthesis, union, left parenthesis, -5, comma, 3, right parenthesis, union, left parenthesis, 5, comma, infinity. Is that what I wanted to type? Yeah, I think so. Now, I want to go back to what we, wait a minute. Here they want us to choose the correct.
You better make it small.
Oh,
shoot, Mike.
yeah. Now they want you to choose the number line. I warned y'all sometime, the last time, now that was the last thing we did, the absolute last thing we did on Monday. I said occasionally on a number line, instead of putting open circles,
I remember that.
okay, I said they put the parentheses and the brackets actually on the number line rather than open and closed. And that's what they've done here for these options. So let's look at our number line.
Look at your. So they have parentheses, right?
A, B, C, or D. Which one?
D.
D.
Yeah, that looks right
Yeah,
to me.
D.
Instead of the open circle, they have parentheses. Now I want to look back. I think we better do this next one also. Okay, but before that, there's something I want to point out. Suppose instead of saying greater than 10, this problem had said less than 10. Would we still have to do this step? This first step, finding the solution cut points, that's the longest part of the problem, correct? Would we still have had to do that even if that had been a less than? Yeah. We would have still said no denominator cut points. We would have still drawn the number line. The only difference, if that had said less, when we tested 0, would it have been true or false? False. And so the shading would have been exactly the opposite. But it doesn't matter with the cut point method. It doesn't matter whether it says less than or greater than. Our method still works. Everything would be the same, except you would have crossed out, shaded, crossed out, shaded, crossed out. Y'all understand that? If you're viewing an example for these problems, what they're doing only works for greater than. It only works in a greater than. What they're doing, they're just thinking about it the way we learned to do it years and years ago. They're just thinking their way through. But their thought process
solves everything that has a less than or greater than.
Okay, so once again, especially for 11 and 12.
They're ready to go, but let's do one more.
Do y'all have time for one more? Do y'all
If you gotta go, just go, but we're gonna do one more.
Number 12.
Oh, God.
Absolute value.
Oh, control
Shift plus.
plus.
X squared plus.
It's not control shift.
Use that plus up there.
Oh, let's see. Where's there it is.
Absolute value of x squared plus x minus 16 is greater than 14. Is it like the one we just did? Yeah. Start off by going equal what and equal what. Find those solution cut points. What will I do first?
Set it equal to positive 14.
And set it equal to negative 14. How do I know that's what I need to do?
Because it's an absolute value equation that you're solving.
I was asking them, Tim.
Oh.
But I'm glad you know why. And I deserve that because I answer your question.
You see how annoying it is?
Okay, so we started off equal positive 14 equal negative 14. And let's solve this one. I'll start off by subtracting the 14. So I have x squared plus x. Negative 16 minus 14, is that a negative 30? Draw your two parentheses. X times x. Second sign is minus, so we have a plus and a minus. I'll go ahead and write them. Ooh, a lot of numbers multiply together to give 30, right? 1 times 30.
2 times 15, 3 times 10, 5 times 6. Which one are we going to use? 5 times 6. Okay, what's going to go after the x plus? The 5 or the 6? The 6, because you need to get back that positive 1x.
Set each one of these to 0 now and isolate the x. So we have x plus 6 equals 0. Move that 6 over or subtract it, however you want to say it. We get x equals negative 6. And set x minus 5 to 0. Add 5 to both sides or move the 5 over. And I should have already asked this, but we have open or closed circles here. Yeah, it's going to be open. Oh no, that's a bad thing. It looks like I wrote SCP greater than 0. Okay, forget that. So we're just going to use open circles. Over here, I'll add 14 to both sides. So we have x squared plus x, negative 16 plus 14. Is that a negative 2? Okay, so still it has the x squared. That's how I know I need to factor it.
And for those teachers that don't like my math lab because the problems are always changing, yeah, but it's changing in a doable way. It's not, oh, now I got to factor 48x squared plus 157 minus 322 equals 0. They're changing in very manageable ways.
Second sign is minus, so it's another plus and minus. Now, only numbers that multiply together to give 2 are
2 and 1. So what's going to go after the x plus, the 1 or the 2? The 2 and then the 1, I agree. So we're about to get 2 more solution cut points.
So we get x equals negative 2 and x equals, what's my last cut point? Positive 1.
And once again, they're all open circles.
Mm-hmm. And there's no denominator cut points because there's no what? Yeah, no
Fractions.
fractions. So can't have any denominator cut points if there's no fractions. Step 3, I draw the number line.
Oh,
Let me see if I can do this without messing up. I put 4 marks.
I'm going to put open circles right now.
Oh, good thinking. I'll put open circles on all of them. And then y'all call them out in numerical order. What goes first? Uh-huh. And then? Uh-huh. Okay. Where am I going to test 0? Oh, what am I going to test 0? Where is 0 located?
Interval 1, 2, 3, 4, 5. Right there in interval 3. It's between -2 and +1.
Now, this is the tricky part when I check here, because if we get a negative number inside these absolute value bars, you're going to have to drop that negative and actually take the absolute value. So first, plug in a 0 in. We have 0 squared, that's 0, plus 0, minus 16. Is that just a negative 16 inside the absolute value bars?
False. That's false.
Well,
Is it false?
what?
No, because it's taking
Oh.
the absolute value.
Okay.
You have to take the absolute value of -16, which is +16.
You've gotten ahead of me. I'm still, okay.
I'm just trying to say something to get their attention. Their eyes are all glazed
I
over.
know this example wasn't a good idea, but you're going to have to do one just like it for homework. And then this one is just like number 11. Do y'all agree? It's just like it. Uh-huh. So
True or
absolute
false?
value of -16 is +16. Now, true or false?
True. So,
Shade X shade. If you're doing these without drawing a number line, guess what?
we're doing something.
Whatever you're doing something wrong. Okay? Now it's just writing out the final answer. Start off parentheses, negative infinity, comma, -6, parentheses, and union, parentheses, -2, comma, 1, parentheses, union, parentheses, 5, comma, infinity, parentheses. I'm going to type all of that in, Tim.
Okay, let me type it in. Oh, goodness.
I bet a lot of teachers don't assign quadratic absolute value inequalities. You can feel very proud of yourself that you can solve a quadratic absolute value inequality. If you can do problem 11 and 12, if you understand how we're doing it, oh wow, you know a lot of algebra.
5, comma, infinity.
Watch it so long.
Oh, yeah, that. Okay. Okay.
Oh,
Oh, wait, we're not through.
ABCD, what graph was it? Is
I
it
think
A?
it's A. Remember, they're putting parentheses instead of an open circle. I told them why I don't like that on the number line, because you don't know which direction when you're labeling the cut points. You don't know, am I going to shade to the left or to the right?
Uh-huh. Yeah.
Okay, so I'm going to